Alrighty, let's have a look at the sine and the cosine functions graphed. In particular, we're going to be interested in these two things. One's called the amplitude and the other is called the period. Alrighty, let me get rid of the cosine of x1. So let's just have a look at the sine of x. You can see that it has these interesting points that appear throughout. It's got this repeating pattern, right? Starts at 0 here, then it goes to a maximum, then it goes back to a middle, and then it goes to a minimum, then it goes to a middle, then it goes to a maximum, then it goes to a middle, then it goes to a minimum. So this is the shape of the function. Now, as with any function, we can dilate this function both in the vertical direction and in the horizontal direction. So we could do that by multiplying it by some constant, a out the front, and by some constant b in the middle. Now, the a function, being that it's on the outside, is going to be our vertical dilator, and the b value is going to be our horizontal dilator. Now, for ease of visuals, I'm actually going to set my axes to go up in a step of pi. Now, that might seem a little bit strange, but I promise to you it will make sense, because now you can see how nicely it actually graphs. You can see that all of these x-intercepts are happening at 0, pi, 2 pi, 3 pi. It makes a bit more sense. So what do we think is going to happen as I change the a value? Well, the a value is going to affect its vertical dilation. So let's have a play with it. Okay, so it's kind of stretching it outwards. And if we actually stretch it to a nice whole number, let's go this up in 0.5s just to make my life a bit easier. You can see that there it's going up to 4. And now the maximums, instead of being at 1, which is where they were previously, are now at 4. And the minimums, instead of being at -1, are now at -4. Because we've basically stretched it out vertically. So we call A the amplitude, because it says how peaks and valleys they are. So if I have an even bigger one, let's say 6, the maximum values are going to be at 6 and the minimum values are going to be at -6. But the median values are going to stay the same because we haven't translated it up or down. Alrighty, let's then reset this one and have a play with B. So B is a horizontal dilation. So as I change this one, you'll see that it, like a spring, it coils back and forward. So it affects what we call its period. So a period just means how long does it take for it to repeat. And as you see, we've got 0, 0, and then at 2 pi. When's it going to repeat again? Well, at 4 pi. When's it going to repeat again? Well, at 6 pi. So it repeats every 2 pi. So its general period is 2 pi. But as we change B, you'll see that that period will actually change. If I change the period to, say, 2, well, let me change it so that it goes up in a nice one. You can see here that now it repeats every pi. So as we increase the b value, it actually decreases the period of the function. And just so you don't think that I'm just lying, let's do the same thing from the cosine function. Now, just so that you can see the difference, the sine function starts in the middle and then goes up. The cosine function doesn't start in the middle at all. It starts at the maximum, and then it goes to the middle, and then the minimum, and then the middle, and then the maximum. But if I edit this function and put in that a and that b, you'll see it behaves exactly the same. As I increase a, it's going to change the amplitude, and as I change b, it's going to change the period. So, given the function y is equal to a sine of bx, or the function y is equal to a cos of bx, these functions have an amplitude equal to a, and in particular the absolute value of a. If a is negative, we didn't actually look at that. Let's just do a quick negative one so we can confirm. Let's go from 2 to -2. Oh, look at that. The amplitude is still 2. It's just that it's been reflected. Alrighty. So the amplitude is the absolute value of a, and the period, which is how long it takes to repeat, is going to be equal to 2 pi, which is its standard period, over the absolute value of b. Once again, if we make b negative, you get the same period. It's just that it's going to look a little bit different. So you can see from maximum to maximum, from minimum to minimum, it's going to happen the same. It's just it's been reflected as well. Alrighty. Now, there's some other things that we can go through. So let's just remind ourselves, the period is how long it takes to repeat. And the amplitude is how far up and down the max and min are. It'll make more sense when we start dealing with translations as well. So, going through these ones, let's work out the different things. Well, A is equal to 2, so therefore the amplitude is 2. And the absolute value of 2 is just 2. The period, on the other hand, is to do with the b value. It's going to be equal to 2 pi over the absolute value of b. Now, b value in this case is just going to be equal to 1, because there's just x in the middle. So it's going to be 2 pi over the absolute value of 1. Absolute value is 1, so 2 pi is going to be the period. So what if I wanted to sketch this? Well, it's not too bad. We won't sketch the entire function because it does go on for a fair bit. In fact, it goes on forever. So the sine function starts in the middle, and then it has 4 key values before it repeats. And it's going to repeat at 2 pi. And in between, there's going to be a maximum, a middle, and a minimum. Now, since the amplitude's at 2, that means that we are going to have the maximum is going to be at 2, and the minimum is going to be at -2. Okay? So where do these key values happen? So we go middle, up, middle, bottom. And this is equal to 2, and this is equal to -2. Well, since this is 0 and this is 2 pi on the x-axis, well, halfway through is going to be pi. Halfway between 0 and pi is going to be pi on 2, and halfway between pi and 2 pi is going to be, let me draw it a little bit more in the half, is going to be 3 pi on 2. So essentially, we're going up by pi on 2 each time. And to finish the graph, I can just draw a beautiful line through it. And then it would just continue to repeat. Alrighty. That's what the function's going to look like. Alrighty, let's have a look at the next one. So the next one is going to be negative cos of 3x. So the a value in this case is -1, and the b value is equal to 3. So the amplitude is going to be the absolute value of a, which is just 1. The absolute value of -1 is 1. And the period, well, that's the one that's really been affected here, is that it's going to be 2 pi on the absolute value of b, which is going to be 2 pi over the absolute value of 3, which is going to be 2 pi on 3. So it's going to repeat every 2 pi on 3. Now the cos function starts at a maximum. So our amplitude says that it's going to be between here and here. The fact that it's a cos function tells us that it's going to start either at a maximum or a minimum. Now, because it's got a negative out the front, that does mean it has been reflected. And because it's been reflected, it's going to start at a minimum instead. And it isn't going to repeat until the next minimum at 2 pi on 3. Alrighty, so now we need to draw the points in between. So it's going to go minimum, middle, maximum, middle, minimum. Alrighty. Now, where are these values going to appear? Well, halfway between 0 and 2 pi on 3, well, that's half of 2 pi on 3, is going to be pi on 3. So this is going to happen at pi on 3. Halfway between 0 and pi on 3, we'll divide by 2 again, that's going to be pi on 6. Now the hard one is working out what's halfway between pi on 3 and 2 pi on 3. But the answer is that we're going up by pi on 6. So all we need to do is work out what pi on 3 plus pi on 6 is. And if you work the answer out, it's actually pi on 2. And so pi on 2 is our final marker here. And that will give us the beautiful reflected cosine shape, which will continue onwards in either direction. And it's just going to keep repeating. And just remember, this is y is equal to 1, whereas this is y is equal to -1. Alrighty, last one is going to be where we have really messed with both the amplitude and the period. So a is equal to 4, b is equal to -pi. And the negative isn't on the outside, the negative is on the inside. So it's not going to be a vertical reflection, it's actually going to be a horizontal reflection. So let's go through and have a sketch. So the amplitude is going to be equal to the absolute value of absolute value of A, which is just 4. The period, now this is the interesting one, is going to be 2 pi over the absolute value of B, which is going to be 2 pi over the absolute value of -pi, which is 2 pi on pi. The pi's cancel, and the period's now going to be 2. So it's not going to be repeating in a strange way anymore. So the maximum line is going to be at y equals 4. The minimum line is going to be at y equals -4. Now, it's a sine function, which means it starts in the middle, goes up, then goes down. But because it's been reflected, you can see that instead of starting like that, it's actually going to start like this, just because it's been reflected. And we can tell it's been reflected by the minus sign there. Now, seeing as though it starts in the middle, it too is where it's going to repeat. That's what the period means, which means halfway in between, it's also going to be in the middle, which is a 1. And then the other two important points are going to be happening at a half and 3 halves. Alrighty, so let's work out the shape of it. So because it's been reflected in the y-axis, it is now going to, instead of starting like this, it is going to be starting like this, which means the next point isn't going to be maximum, it's going to be a minimum. And then from there, another maximum. And there is our shape. This would be 3 on 2, and this would be 1 on 2. So it's going up in halves. And again, this will just continue on forever and ever. If you want to get a better sense of why it's repeating with these periods, my suggestion is to have a look at the unit circle. Because these values here repeat. We get 0, and then we get 90, and then we get 180, and we get 270, and then we get 360, and then it's going to continue to repeat. After 360, well, add another 90 is going to be 450. Add another 90, and it's going to keep repeating. If we do this in radians instead of degrees, it looks the same. Pi on 2, pi, 3 pi on 2, 2 pi. And then the next one is going to be 5 pi on 2, 3 pi, 7 pi on 2, and it's just going to keep on repeating forever and ever and ever. And the reason why sine starts at 0 and cosine starts... the reason sine starts at 0 and cosine starts at 1 is that cosine starts at 1 and sine starts at 0. It's all really based on the unit circle in the end. Alrighty, I'll see you in the next one. Goodbye.